Thank you very much. Thanks everyone to coming to my talk. My name is Vladimir. I'm CTO at DoubleCloud. And today I'm going to talk about building a scalable and low-cost observability solution. How we did it and first of all, let me introduce myself, just a couple of words. I started working with data more than 10 years ago as a Postgres DBA. Where I was responsible for moving a huge web service from Oracle to Postgres. Then I switched to a developer role, and we were making the first managed ClickHouse service in the world. Later, I switched to a managing position, and in one local cloud provider, I was responsible for the whole data platform department for product and engineering part. And last year, we co-founded a DoubleCloud startup where I'm now a CTO and responsible for the engineering team. So what is DoubleCloud? DoubleCloud is a platform for building sub-second analytics on top of clickstream data. Clickstream is, I don't know, logs, events, metrics, and so on. And in the future, we are going to develop it into open source modern data stack. And tomorrow we are giving a meetup here in Tel Aviv. So offline event, so please enjoy coming to us and having a talk with pizza and drinks tomorrow at 6 p.m. So the QR code will also be in the end of the presentation. What am I going to talk about today? About observability. Actually, this talk would not be interesting for data scientists and guys who are mostly interested in AI and machine learning, but it would be interesting for data engineers, software developers, and DevOps engineers, for all the people who monitors their production and needs tools for debugging what really happens. So let's start with a definition of what I call an observability solution or observability platform. So what we want is to provide a better experience for our customers. And to do that, we need several things. So first of all, we need to be sure that our service works with good uptime and performance. It's stable and it's fast. And if something goes wrong, we should have a fast way to debug what really happened and why, and fix it proactively before the user actually gives us a signal that something is happening. And it is in the world, people usually think of three main things when they are talking about observability. That's logging, metrics, and tracing. And there is a cool idea, and it probably will become a standard in the future called open telemetry, which combines all these three things into one solution. Well, the idea is great, we like it really, but there is no good implementation right now, and actually the API is still unstable. So when we started building observability for ourselves, we started solving these three problems, each in different way. But I think that in several years, open telemetry will become the standard. So a couple of important things about our infrastructure that you should know to understand some of the things I'll talk about. First of all, we have our service has two main parts, control plane and data plane. Well, a control plane is a bunch of microservices deployed on Kubernetes managed by AWS. And we have several development teams which are independent. So each of them has its own AWS account, has its own Kubernetes cluster. And it's kind of a best practice running services and maintaining them on AWS from security point of view and from ease of maintenance. For control plane, our runtime is Kubernetes, and we have several AWS accounts. Right now, 7, I think, for production. And well, a control plane is a bunch of APIs who actually provide you APIs like, I don't know, to create a Kafka cluster or to start transferring data from Google Ads to ClickHouse or something like that. And we have a data plane part. So when you actually through our control plane API create a ClickHouse cluster, we actually create those virtual machines in a data plane account in your own VPC. So the runtime there is EC2 instances in AWS. And important thing is that each user is isolated from any other users. So for example, if two users have two projects, we have an abstraction of project, and they create two clusters, I don't know, of ClickHouse, for example. These ClickHouse hosts, well, actually are deployed into separate EC2 instances in separate VPCs. So these details would be important later in my talk. So let's start, and let's start with a tracing solution. It's kind of the easiest part. If you're not familiar with tracing, so here is how Jaeger UI looks like. So it's a convenient way to debug performance of your applications and see where are the performance bottlenecks. So here you can see the path of a gRPC query to our API, which took, well, actually it was quite fast, 36 milliseconds. And you can see all the steps that were issued while serving that request. Each line here is called a span in terms of tracing solution. And well, that's really convenient way to debug slow queries or something weird situations. So this is how it looks like in terms of our architecture. As I mentioned, we have a Kubernetes cluster, one per team. There is an application which is instrumented with SDK, a special SDK, which sends tracing points on interesting for us events. For example, request to another API or request to the database, to the cache or something like that. So application is instrumented with a special SDK. They're open source and they're available for all programming languages. There is a Jaeger collector that's actually an agent deployed on each Kubernetes node as a daemon set. So, and application sends it to the collector. Collector actually collects data into batches and sends them to Jaeger server, which is deployed in a separate infraplane AWS account in separate Kubernetes cluster. And as a storage for all this data, it uses ClickHouse. And this ClickHouse is managed by ourselves, by DoubleCloud. So we are dogfooding our own service. That's one of our ideas. For that to be available, there is an open source project where we are heavily involved. It is called Jaeger over ClickHouse. That actually gives the ability for Jaeger to store the spans in ClickHouse. Jaeger supports different storage types. So this is one of the implementations. These are the numbers of one of our clients. That's not our numbers because we use tracing only for control plane. There is no really heavy load there. But one of our clients uses our managed ClickHouse service exactly as a Jaeger backend. That client is actually a high load web service. Unfortunately, I can't call the name of the company, but the numbers are really impressive. So it's 150 terabytes of uncompressed data. And the good thing about ClickHouse is the compression ratio. So it's more than 10 times. So on disks, you consume only 15 terabytes actually. And they are able to store data for last 4 days actually, because the more days you store, the more storage you consume, and that becomes quite expensive. The insert ratio is really high. It's more than 500,000 spans per second, and each span is represented with 2 lines in ClickHouse. So it's approximately 1 million rows inserted per second. And when you query the data, as I showed you on the screenshot above, it takes you less than a second to get the results. And for all that, you need only 160 ClickHouse cores. They have a cluster of 5 shards, each of which is 2 replicas for high availability. And that is approximately 3 terabytes of data per host. If you will buy that ClickHouse cluster in DoubleCloud, that would cost you approximately $16,000 a month, quite a lot. But as I mentioned, that's a really high load web service with a huge amount of data and inserted spans per second. For us, for our control plane needs, we use a much smaller cluster, so it costs us approximately $300. And our peak insert rate is 1,000, and this is peak. So actually average is even less. And we store spans for 30 days. We can afford it because it's cheap. So this solution is really low cost if you will compare it with Jaeger or Cassandra or other solutions that would cost you much more money. And it is really scalable. So you can start with a cluster of 4 cores actually and scale it to hundreds of cores. So this is how we do tracing. And let's switch to the next topic, to the logging. And that is probably the most interesting part of my presentation. Of course, we started with a simple approach, which probably the whole world uses. So you just have an agent that collects logs that may be Fluent, Beat, or Vector. We actually prefer Vector. That's an open source agent developed by Datadog. And it sends all your logs to Elasticsearch, and then you view them with Kibana. But this solution has several drawbacks. Well, actually, when you have several teams, you have 2 approaches of how you deploy and scale your Elasticsearch clusters. You can have a cluster per team. It makes it easier in terms of scaling, but it's quite expensive. And for teams who need access to logs of several teams, like support guys or SRE team, it's hard to find needed logs because there are different installations of Elasticsearch cluster in different accounts, different ACLs, and so on. So the more common approach is to have a multi-tenant cluster. When you store all your logs in a single Elasticsearch cluster, that's lowering your cost, and you have a single point of access to all the logs. But of course, there are drawbacks of such solution. First of all is the best radius. When some team, for example, starts writing lots of logs into your Elasticsearch cluster and it goes down, all the teams can't see their logs. Well, we actually had a production incident when we need logging for debugging, and it didn't work because another team wrote Elasticsearch too much, and it didn't work. So, and it is also a bit complex to maintain ACLs inside one Elasticsearch cluster for different people, and scaling that cluster because you don't actually know the needs of different teams. So we're not as big to have that problems a lot, but we started seeing them. There are bigger companies like Uber who saw a lot of that problems, but of course they are much bigger than us. But a year ago they made an article about how they moved their logging solution from Elasticsearch to ClickHouse, and we were inspired by that article and thought that we can build pretty the same solution. So this is how our logging solution looks like. This is a picture for the control plane part. There is still an application deployed in Kubernetes. There is an engine, we use Vector, that collects logs from all the applications and sends them to Kafka as a distributed queue. Then there is a transfer that pulls data from Kafka and sends it to ClickHouse. And all these components are managed by ourselves. So we are, again, dogfooding our own service. to be sure that we provide a good service to our customers. We use it ourselves. And after the logs are in ClickHouse, there are two ways of viewing them. The first one is our own web interface. So we give a way to our end users to see the logs of data plane, for example. And for us, there is an interface through Grafana with a plugin and a special query backend. I'll give a couple of more details about them 2 slides later. That is how it worked for control plane. And for data plane, it's a bit more complicated because we have lots of EC2 instances in different virtual private networks in terms of AWS. So each host, each EC2 instance also has a vector engine which collects all the logs, but it doesn't send it directly to Apache Kafka. It actually sends it to vector aggregator in control plane, and then the flow is exactly the same as for control plane logs. The reason for that is a network connectivity issue. I'll describe it in more details in the last part of the presentation. So you may see that on the previous slide, there is a transfer service provided by DoubleCloud, which pulls data from Kafka and puts it into ClickHouse. Well, that's not open source. So if you want to build this solution on your own without using our service, you can do it with a couple of alternatives, which are open source. The first one is a native support for Kafka engine in ClickHouse. And the second one is actually Airbyte. It has a source connector for Kafka and destination connector for ClickHouse. So if you want to build that solution on your own, you can do it with open source alternatives. But we use our own service for Dogfooding. So this is a short demo of how our Grafana UI for querying logs looks like. You can see that there is suggest here. There is a cool feature of deduplicating messages, lines of logs. And of course, there is a full text search. You can filter by any string. And as you can see, you get the results with the sub-second latency. So that's a really convenient way to work with logs. We like it a lot. Here are our numbers. These are our numbers, not one of our clients, because we really love to write lots of logs, so that it would be easier in the future to debug any weird situation. So we have 0.5 petabytes of uncompressed data. It's more than 1 trillion of rows. We store them for last 30 days. And actually the data is inserted with an average rate of 500 megabytes per second. And the peak insert rate is twice as bigger. And we still have a sub-second query latency for getting results of fresh logs. So for example, if you query logs for last 3 days, it would be fast. If you query logs for, I don't know, 3 weeks ago, that would take time. That would not be sub-second latency, but you don't do it really often. And for all that 0.5 petabytes of data, you only need less than 200 ClickHouse cores. We use free shards, and again, with 2 replicas per shard for high availability. And the game changer here is a feature called ClickHouse over S3, which our team heavily participated in developing in upstream ClickHouse. So there are 2 disk types in ClickHouse. One of them is actually what you store on SSD disks. So from 0.5 petabytes of data, you store on SSD only 8 terabytes. And all other data is stored in S3. And it is also compressed, so the compression ratio is quite good. So, from an application point of view, you don't know anything about it. So you just write data to ClickHouse, and ClickHouse itself stores fresh data on SSD and moves old data to S3. And it's really a low-cost solution. So The core solution with ClickHouse cluster, with S3, with Kafka cluster, costs us approximately $20,000 per month. And if you calculate it for half a petabytes of logs, it actually $40 for 1 terabyte of logs per month. And it is literally more than 10 times cheaper than any other ready-to-go solution on the market. But of course, there is a cost for people who maintain all that solution, but for us, for our amounts of data and load, it is still cheaper than ready-to-go solutions like I don't know, Datadog, Grafana Cloud, and many others. Here is a comparison of using ClickHouse cluster with the turned-on feature ClickHouse over S3 when you store fresh data on SSD and old data on in S3. And the cluster, when you store all your data on SSD, it's more than 3 times more expensive for you. So ClickHouse over S3 is really a cool feature. We use it a lot. Of course, our solution is not ideal. There are the drawbacks. First of all, the Grafana plugin and query backend are not open source, at least yet. So we wrote it for our own, but it's not open source. But there are a couple of open source alternatives. There is a project called CLoki, and recently Grafana released the ClickHouse plugin support. So if you'd like to build your own on your own, there is a way to do it. The second minus of the solution is that the solution is highly coupled with log scheme. So if you want to query your data through Grafana in a convenient way, your application should write your logs in a precise format with precise fields. And well, it makes it a bit more complicated than we wanted. And right now it is deployed in a single region. I'll give an overview of it in the last part of my presentation about our multi-region setup. So let's switch to metrics. Well, metrics is probably not that interesting as to previous topics because we use Prometheus. And we actually use Prometheus managed by AWS. It is called AMP service. So for control plane, each our application exposes Prometheus endpoint. There is a Prometheus deployed in the same Kubernetes cluster, which gathers all the metrics from all our applications and then writes it to Prometheus managed by AWS with a remote write API. That's for control plane. And for data plane, it's a bit more complicated. We use Telegraph as an engine for collecting metrics in data plane because we write lots of modules to it to gather the metrics we really want. And we also provide a Prometheus endpoint on each host so that the user with his own Prometheus can gather metrics from our data plane if he wants. Because usually people already have a Prometheus and they want not only see the logs in our web, the metrics in our web interface, but also in their own monitoring solution. So Telegraph sends data to vector in control plane. Sorry, I'll turn off the light. It's weird. Sorry. Yeah, so the Telegraph sends metrics to vector aggregator deployed in control plane in a similar way as we do for logging. And then vector doesn't write it directly to Prometheus managed by AWS because AWS Prometheus requires a special signature for requests and vector actually doesn't support it yet. So Vector exposes a Prometheus endpoint as our applications do. Prometheus gathers those metrics and then sends it to Prometheus managed by AWS. And we also have 2 entry points, one for users, we show the metrics in our web interface, and another one for us, we use Grafana. our dream is to make sometime in the future Prometheus over ClickHouse, because that would lower our cost for storing metrics. And actually using Prometheus managed by AWS is a cool solution. We don't need maintaining it, but well, it's a kind of cloud log, and we are building a cloud agnostic solution. So what we want to have is Prometheus over ClickHouse for storing metrics. So a couple of things to notice about maintaining all the solutions on AWS. This is the most deep part from infrastructure point of view, but don't be scared. Feel free to ask any questions if you have them. So first of all, as I mentioned, we have lots of AWS accounts and lots of VPCs in data plane. So there is a problem of cross-account network access. AWS provides several tools for that, like VPC peering, transit gateway, endpoint interfaces, and unfortunately, we use all of them. So let me describe how we do it. So as I mentioned, two different projects for two different users have two different VPCs in data plane account. All of them, so let's look into it, for example, for logging. So there is a vector agent in each VPC, which needs to send it to vector aggregator and control plane account in VPC. So for that, all data plane VPCs are connected to transit gateway. That's an AWS service, which is deployed in control plane. And vector actually is the VPC is connected to transit gateway, and vector using that transit gateway routing sends data to a network load balancer on top of these vector aggregator pods deployed in Kubernetes. So that's the way how data is sent from data plane to control plane. But then vector aggregator should send that data into Kafka. And as I mentioned above, we are dogfooding our service. So Kafka is deployed in DoubleCloud, and it is a data plane in a separate VPC. So we need to push the data from control plane network to a special network in data plane. And for that, we use our feature called VPC peering. We give to our end users an ability to peer our VPC where we provision our clusters and other resources with users' own VPC, so that the traffic is not going through the public internet, as it's important from a security point of view, and from the cost point of view, because traffic through VPC peering doesn't cost you money, while the traffic through public internet does. So that's how the way the traffic goes from one data plane VPC to a control plane VPC, and then back to another data plane VPC. We use transit gateway and VPC peering. As for connecting from another AWS account for control plane, well, it's really easier. We use endpoint service and endpoint interface there, so it's really much simpler than for data plane part. And all that whole picture is actually for a single region, while we provide our service worldwide in different regions, and it becomes even more complicated. So there are two ways of storing your logs in a multi-region setup. One of them is to store it in a single region. So you have a single point of access. It's easily for you to maintain it, but you have a network traffic cost for cross-region traffic, and you may have some data residence issues because different countries may require different things about data in logs. So, and another approach is to store logs in the region where they were produced, so that is by default compliant with all the data residence requirements. There is no network cost. but actually you need to deploy a solution for storing logs in each region, and that's some kind of a cost. And you lose a single point of access to all logs. That makes it a bit more complicated in terms of maintenance. So as of now, we use the first approach, and in the future we plan to have some kind of a mixed approach where we have an abstraction of home region where most of the logs are stored. But when some of the regions becomes really big in terms of amount of logs or of network traffic, or in some regions there are special data residence requirements, we deploy the installation of our logging solution in that particular region. But as of now, we use a single region. So as a conclusion, I think we have some time more. This is how our stack looks like. So most of the components are open source, all except one, that's our transfer service. But I mentioned open source alternatives above. So we use Vector and Telegraph as agents for collecting metrics and logs. We use Prometheus for metrics. We use Jaeger for tracing, Grafana for looking into metrics and logs, ClickHouse as our main storage for logging and tracing, Kafka as a distributed queue for logging, and transfer for transferring data from ClickHouse to Kafka. So you can build it on your own. That's one of advantages of our solutions. It's open source, so it's cloud agnostic, and you can take it and build it even on premise, for example. So another two main advantages is that it is scalable. So you can start with, for example, gigabytes of logs and hundreds of dollars per month, and then scale it to petabytes with, I don't know, several hundreds of shards. So on my previous work, we had a ClickHouse cluster with 150 shards, storing several petabytes of already compressed data. So ClickHouse is a really scalable solution. And the main advantage is the cost of the solution. So $40 per terabyte of logs is literally more than 10 times cheaper than other ready-to-go solutions. And when you query your logs or traces, you get sub-second latencies. And as I mentioned in the beginning of the presentation, we do all that to have a good observability of all our platform to provide a better experience for our customers. So what we plan to do in the future, as I mentioned above, we want to make Prometheus over ClickHouse to become cloud agnostic and lowering our metrics cost. There is a couple of things to do in terms of security and stability. For example, our ACL for logs is not ideal right now, so it's really high level and divided by team, but we need a per log ACL. And we don't have, for example, throttling per client. So for example, if one user creates I don't know, ClickHouse cluster and starts writing lots of logs by the ClickHouse cluster, other users of our system may suffer with delays in seeing their logs. So we have right now just a global limit. And as I mentioned, we write more than 500 megabytes per second of logs. So we need throttling per client so that if one client makes something weird, that doesn't affect all others. And one of the things we are heavily thinking about is about open sourcing our Grafana log kill plugin, because it is convenient for us to use. And probably many other users in the world would also find it a convenient way for viewing logs. So that's probably all I wanted to say. Thank you. I'm ready to answer your questions.